studying the effects of this metabolic syndrome of insulin resistance, how it develops, why is it that some obese people seem to be able to avoid it, but others actually develop it, why do some go on from metabolic syndrome into full-blown diabetes and others don't. These are all questions that we're actively involved in. This is the model that I think most of my colleagues certainly here would agree with, that what comes first is our diet rich in saturated fat and sucrose. That leads to an increase in weight and accumulation of adipose tissue. It's that tissue that first of all becomes resistant to the action of the hormone insulin. That then leads to a release of fatty acids into the bloodstream. Those fatty acids are then responsible for making other tissues insulin resistant, such as the liver and your muscle tissue. That resistance of it for insulin in your liver leads to this non-alcoholic fatty liver disease. All of these then go on to cause other problems, changes in your plasma lipids, high blood pressure, impaired glucose tolerance. We've got these molecules being produced by the adipose tissue, these pro-inflammatory, what are called adipocytokines. All of this then goes together to increase your risk of atherosclerosis. Or you go on to develop type 2 diabetes, and that further increases your risk of atherosclerosis. And that's the whole rather depressing picture of the effects of obesity at the moment. What we are hoping to do is to develop a good animal model of this. And that's been incredibly difficult. Most of the studies which have been done so far have been done on rodents. As I've said before, it's very hard to get a normal rat to get fat. It's very hard to get a normal mouse to get fat. If we really want to understand these processes, we do need a good animal model. And a number of us have got a grant application in at the moment to study this chap. This chap is the mini pig. He's not that mini. A full-grown mini pig is about 70 kilos, so he's still quite a hefty beast, but considerably smaller, as many of you will know, than a full-blown domestic pig. Now, the pigs we actually produce to produce meat have actually been bred over the decades to be lean. And they're not a particularly good model. But these guys are much closer to their original ancestors. And they're scavengers. And they have to go through periods when there's no food available. Then they'll go through a period when there's a lot of food available. And to survive that, they'll eat a lot when there's a lot of food and live off the fat when there isn't a lot. A bit like we actually evolved. So this makes a much better model in many ways. Apart from the fact they cost about £1,000 each. What we're hoping to do is model metabolic syndrome in the mini pig and look at whether our theory as to which tissues become insulin resistant first is right. And then obviously we can then intervene with different dietary or pharmacological interventions to try and prevent obesity actually falling over into metabolic syndrome and diabetes. Okay, some more positive stuff on the actual work we're doing. I just want to go through two examples of the sort of thing that we were involved in. One is actually trying to increase the amount of good fat in our diet rather than worrying about the bad fat. And then the other one is a major research interest of many of my colleagues, and that is how what a mother eats during pregnancy can actually impact on the diseases that their offspring develop many, many years later. Good fats. Well, the one on the left, I can almost guarantee that every one of you have heard of. Omega-3s, fish oils, have been pushed at us now for at least 20 years for their potential health benefits, one of which is to reduce your risk of developing heart disease. We can go into any chemist and buy a supplement of omega-3, and indeed we know that many of our foods are specifically supplemented with it. I'll talk about that in a moment. The one on the right may be less familiar to you. This is called conjugated linoleic acid, and you can buy this in some health food stores in a tablet form like this, but it's only in the last year that approval has now been given to actually supplement foods with conjugated linoleic acid, both in the United States and in Europe. So we may start to see milk and yogurt and things like that which have been specifically supplemented with this. But if we want to change our fat intake from diet, then what do we have to do in terms of changing the fat composition of our diet? Well, if we look where the bad fats come from, unfortunately, the majority of them come from animal products. So we've got milk and milk products on the right there, about a quarter. We've got meat and meat products on the other side, about another quarter. We've got butter there, which is only about 4% now. So if we could actually alter the fat composition of the meat, of the milk, put some of these good fats in it and replace perhaps some of the bad fats, could we actually have a much more wholesale effect on the whole health of the nation? That's what we call the fatty acid composition of normal milk. No fat has one single type of fat in it. It'll have a mixture of fats. Now, milk is thought of as bad because it has a lot of saturated fat. And that's the bars that I've shown in red there. 12 naught, 14 naught, 16 naught refers to the number of carbon atoms. The naught says there's no double bonds, so it's saturated. But it does have some of the fatty acids in it as well. You've got this big greeny yellow bar there, which is the oleic acid, the monounsaturated fatty acid, which most of us believe is quite good for us. And then at the far end here, we have some good fatty acids. We have some polyunsaturated fatty acids in milk, in very small amounts. And then we have this, conjugated linoleic acid, which I mentioned, a tiny amount of it. But even though that's tiny, milk represents by far the major dietary source of this potentially good fatty acid. And over the last 20 years or so, it's been claimed that CLA, or conjugated linoleic acid, has benefits on a whole range of aspects of health. There's some really reasonably good evidence that it might be anti-carcinogenic. It may reduce the amount of fat in your body, altering nutrient partitioning. It may reduce your risk of developing diabetes. It may boost your immune system. It may improve your bone mineralization. It all seems a little bit too good to be true, and some of them, I think, won't actually turn out to be true. But repeatedly, there's evidence to suggest that it might have anti-atherogenic properties. It might reduce your risk of developing atherosclerosis. Atherosclerosis is the underlying cause of heart disease. So for a number of years, I've been working with my colleagues who are animal scientists, and this work started with Phil Garnsworthy and a PhD student of his, Adam Locke, and then progressed when Adam went to work in the States to work with somebody called Dale Bauman over at Cornell. And we can actually increase substantially the amount of CLA in our milk by changing the diet of the cow. If you give the cow some oil, some sunflower oil and a little bit of fish oil, you can increase the amount of CLA in the milk by about tenfold. So Adam and Dale did this out in Cornell. They produced this butter. They sent it over to me, and I tested it in an animal model of looking at the effect on plasma cholesterol. Story behind that, it arrived at East Midlands Airport by DHL right in the middle of summer on one of the hottest days of the year. And I was desperately waiting for it, and finally got through to somebody at DHL. I said, oh yes, it's here, it's in the warehouse. And I was saying, well, can I have it? And they're saying, no, you can't have it till tomorrow. And I was saying, but it'll all have melted by then. And they just couldn't understand why I was so upset about these few kilos of butter. I finally got it because a woman who worked there's husband had just had a heart attack, and when I started explaining what I was doing, she let me in. I had to go into the warehouse and get it. But otherwise, none of this would have happened. The animal model I used was the hamster, and believe it or not, the hamster has many similarities to us in terms of how it carries the cholesterol in its blood. Other rodents like mice and rats aren't as good. The hamster carries quite a lot of cholesterol in the bad fraction, like us, the LDL fraction. So for many years we've used this as a model for humans. We took groups of hamsters and we either fed them on normal butter or CLA-enriched butter, and we got a very nice result. Total plasma cholesterol on the far left-hand side there went down. LDL cholesterol, the bad cholesterol, went down. There was a non-significant increase in the good cholesterol, the HDL cholesterol. So our LDL-HDL ratio, which tells us how much at risk this chap might be of developing atherosclerosis, went down substantially, almost by 60%. So by increasing the amount of CLA in our butter, we actually made it a healthier product. It decreased plasma cholesterol. We're very excited about that. But there was something I didn't show you.